Hi, this is John Linneball from John Linneball Tutoring, and this is Barron's SAT Premium Study Guide, Chapter 6i, Lines and Angles. So we're going to cover Chapter 6i of Barron's SAT Premium Study Guide, as you might guess. And for the best results, I do suggest you go and get a copy of Barron's SAT 30th edition. Doesn't have to be the Premium SAT Guide, can just be the regular one that I just found out existed today. And if you can't get that, or you need to save money, look for a 29th or a 28th edition. The page numbers are the same in the 29th edition, and they're identical or close enough in the 28th and previous editions. Barron's is pretty conservative. When they have a good problem, they usually keep reusing it in new editions. But anyway, you shouldn't use an edition older than Barron's new SAT from 2016 in any event. Please take notice. Not everything in the book is in these questions. You do want to read the book because there are things that are in these subchapters that aren't in the review questions at the end of the subchapter, which are the only things I'm going over in these videos. The older editions of this book can be had cheaply, if not for free, from used booksellers, kids who've already taken the test, and public libraries. They sell old editions, or you can borrow the current edition. If you plan to use a library copy or a new edition, I do suggest you start early. There's no worse feeling than needing a library book someone else has checked out, or trying to buy a review book that's sold out. And come on, you're really not going to learn this thing a week or 3 days or something like that before the test. Just get the book early, do it a little at a time. You'll feel a hell of a lot better. Okay? Excellent. Question 1. Excuse me. Page 557. All right. So here's the diagram as in my book that I've written in. And we see in the figure below, what's the value of B? Well, we see an angle labeled as 4A degrees, and it's vertical to 2B. So we know vertical angles are equal, so 4A must be equal to 2B. So we can write that this is 2B, because 2B or not to be, that is the question. No, actually, what is the value of B is the question. Ha ha ha. So okay, 2B, 2B. And then, since 4A we already know is 2B, we can write 2B here. This is vertical, that's also 2B. Since this is 2A, it's got to be half of 4A, which, since 4A is 2B, that means this is B, this is B. Yes, I'm sorry that my B's look like 6's. Oh well. Anyway, so we fill in the diagram. We see that 2B plus 2B plus B is 180. We see on the other side, it's 2B plus 2B plus B. That's also 180. So we add these together. 2B plus 2B plus B is 5. 2 is 5B. 2B plus 2B, another 5B. So that's 10B equals 360. So B is equal to 36, which is choice C. So in the figure below, what is the value of x if y to x is 3 to 2? Well, we know when we're working with ratios, we should probably put x after, but we're already using y and x, so let's make it z. 3z plus 2z, but we don't know what it's equal to. Oh, okay, what am I going to do? Well, we see x and a right angle and y equals 180 degrees. How do I know it's 180 degrees? It's a straight line. So I have a 90-degree angle here, fine. I can subtract 90 from 180, so we end up with x plus y is equal to 90, as I wrote here. So we can say 3z plus 5z is equal to 90, and we know that 90 is equal to 5 times 18. So 5z is equal to 90, z must be equal to 18, and since x is equal to 2z, remember it's not equal to z, x is equal to 36, which is choice C. Okay. Question 3, page 557. What is the measure of the smaller angle formed by the minute and hour hands at 150? First, draw a diagram. So you won't have a nice picture of a clock, but you'll probably be in a room that has a clock on the wall, especially if you're, I don't know, most schools in the U.S. built in the last 100 years have a whole system of clocks where they're built right into the wall or they're attached to the wall and they can be remote controlled from the principal's office or whatever. At least those were the schools I attended. But enough about me. Okay. So we know that a clock face is a circle, so we know this has to be 360 degrees. Since the hour and minute marks are all the same size, they have to be, or a clock wouldn't work right, has to be very uniform and work like, dare I say, clockwork. Ha ha ha. Aren't you so glad you get to hear these horrible jokes? Anyway, but since the hour and minute marks are all the same size, we know that there are 360 over 12, because there are 12 numbers. So that would be 360 degrees divided by 12, so we know between 12 and 1 is 30 degrees. 1 and 2, 30 degrees. 30 degrees between any two consecutive numbers here. So since it's 150, we know that as this minute hand and the second hand move, this hour hand moves ever so slightly. Since we know it's 30 degrees and we know it's 50 minutes past the hour, we know that it's moved 50 minutes, so it's moved 50 over 60 minutes, or 5/6 of an hour. So 5/6 times 30, because we know this is 30 degrees, is 25 degrees. So we know the distance between here and what this is pointing to should be 25 degrees, and it looks like it might be off by a little bit, but not by much. So anyway, that's 25 degrees. And we know this is 30, 10 and 11, 30, 11 and 12, 30, so that's 60, 12 and 1, okay, that's another 30, so that makes it 90, plus the 25 from here to here is 115. So that's answer C. Okay. Question 4. Concerning the figure, if A equals B, which of the following statements must be true? All right, must means has to be true, needs to be true. Whatever you say when something is absolutely, positively has to be that way, that's must. If it could be true but doesn't have to, it would say may. That's going to be important later if you're ever dealing with legal documents. If someone says, well, we may do this, yeah, they also may not do this. You know, we may keep your information private. Yeah, or we might give it away to everybody we want to, just because we can make more money that way. So look for must as opposed to may if you want something to be sure that it has to happen. All right, so notice this figure is not drawn to scale. Translated from SAT language, that means we are messing with you because this problem would be too easy otherwise. So the good part is it would probably be easy if they drew it to scale. The bad part, of course, is they didn't draw it to scale. So that means you can tell nothing by looking at this figure other than what lines are straight. Okay, they're not going to do some weird optical illusion or curved line or something. You know, they can't do that. Or what is explicitly labeled. If they put the little box here, that would mean it's 90 degrees, but there are no little boxes, so we don't see anything. It doesn't say that anything is parallel to each other or anything is perpendicular. So all we know is A and C add up to 180 degrees, and B and D add up to 180 degrees, and they tell you A equals B. Okay, so we know that A plus C is 180 degrees, then A equals B, so then B plus C would also be 180 degrees. So we can see that B and D add up to a straight line, so B plus D equals 180. So therefore, B plus C is equal to B plus D, since they're both equal to 180. And therefore, C must be equal to D, because B plus C adds up to 180, B plus D adds up to 180. If you subtract B from both sides, you're going to end up with C equals D. So, 2 and 3. L and K are parallel. It sure looks like it in the drawing, but it's not drawn to scale, so we don't know. M and L are perpendicular. It looks like it in this drawing, but they tell you it's not drawn to scale. So we can't know that. It doesn't have to be like that, so we don't know that it's true. So only choice 1 is true, and that is choice B. So that choice B is correct. Question 5. In the figure below, B and C, okay, we got B here, C here, lie on line M, or lie on line N, rather, and I cut off the N here, oops. M bisects AOC, so M is over here, that's also cut off, that's unfortunate, but okay. So we have line M, and line L bisects AOB, okay, so here we go. And what is the measure of DOE? So notice that AOC, my favorite congresswoman, and AOB add up to a straight line. So what are we doing here? Okay, since these add up to a straight line, we know that AOB and AOC have to add up to 180. And they're telling you that L bisects AOB and M bisects AOC. So the M would be here if this weren't cut off. Oh well. Anyway, so E is on line M. Okay, anyway. So DOE is going to be equal to 1/2 of AOB. Why? Because this is bisected it, so this bisected it, so that's got to be half of it. and 1/2 AOC again because it bisects it, so it literally cuts it in half. So it's going to be half of these two angles. Well, okay, so DOE is equal to half of AOB plus half of AOC. We can factor out the 1/2 to get DOE is equal to just 1/2 of the sum of AOB and AOC. And remember, AOB and AOC add up to 180. So that's 1/2 of 180 degrees, which is equal to 90 degrees, which is choice B. Okay, question 6, page 558. So, in the figure, what is the measure of B minus A over B plus A? Well, we see that 1, 2, 3, 4, 5, 6. 6A's equals a straight line, which is 180 degrees. 1, 2, 3, 4, 5. 5B's is also 180 degrees. So B is equal to 180 over 5, which is 36 degrees. Angle A is 180 over 6, which is 30 degrees. So B minus A is 36 minus 30. B plus A is 36 plus 30. 36 minus 30 is 6. 36 plus 30 is 66. That simplifies to 1 over 11. You ever see the movie The Omen? That's kind of like what the little birthmark on Damien's neck looked like, on his head, whatever, under his hair. Scary, kids. All right. So, question 7, page 558. In the figure below, A to B is 3 to 4, and B to C is 1/2. I really hate this colon notation. I wish they would use the fraction notation. But, whatever. They do this to make it harder, I think. So, what is the measure of the largest angle? Okay, so first notice the figure's not drawn to scale, so you can't tell anything by looking at this. And second, you want to use the two ratios to make an extended ratio. So an extended ratio would just be A to B to C, so it'd be A colon B colon C. So I guess colons are pretty useful for extended ratios. But anyway, so the trouble is we can't have B be equal to 4 and B also be equal to 1 in an extended ratio. That's not going to make sense. You can't have B two values. Ha ha ha. So, just like with a fraction, what you can do is you multiply both parts of the ratio by 4 to get B to C is 4 to 8. So it'd be like if you had a recipe and you had to quadruple it. You understood, oh, okay, well, it's 1 to 2. All right, so I'm going to use 4 of whatever, one ingredient and 8 of the other ingredient to have the same ratio. So, as long as you multiply both parts by the same number, you haven't changed the value. So that's why I do like ratios written like fractions, A over B, rather than with the colon notation, A colon B. So, since A to B is equal to 3 to 4, and B to C is equal to 4 to 8, then A to B to C is just 3 to 4 to 8. This is a good use of the colon notation, so even though I hate the colon notation, if you have more than 2, it's kind of easier to use. Alright, I'll give the colon notation people that. So, we can write the equation, just put an x after everything like they teach you in the Barron's book with ratios. 3x plus 4x plus 8x is equal to 180. So 15x is 180, so x would be a part or a share. Anyway, when you do the math, 180 over 15 equals 12, x equals 12. So the largest angle is 8x, which is angle C. 8x times 12, 8 times 12 is 96. Yay! So we can see 3, 4, 8 here. So we see this is the biggest one. All right. Question 8, page 558. A, B, and C are points on a line with B between A and C. Let M and N be the midpoints of A, B, and BC, respectively. So we have A to B, M to B. Okay, so M is the midpoint of AB. So if this is 3, so AM and MB have to be 1.5 because M is the midpoint, so it's exactly halfway. And we know B to C is 1, so B to N, N is the midpoint of BC, is 0.5. N to C is also 0.5. So we want to know if AB to BC is 3 to 1, what is the ratio of AB to MN? Alright, we already know that AB is 3. Because we have a ratio, we might as well just have it be 3 units. So, MN, okay, M is going to be 1.5 plus 0.5, so that's 2. So AB to MN is just 3 to 2, or 1.5 if you want to write it as 1.5. So, there's your answer. Okay, have 1.5 plus 0.5 is 20. Obviously, that's a mistake. 1.5 plus 0.5 is 2.0. So, dope. All right, so the ratio is 3 over 2, or 1.5. In the figure, lines K and L are parallel. What is the value of y minus x? The easiest way to solve this problem is to extend the lines. We see from the transversal that x plus 45 equals y, so y minus x is 45. If you're ever unsure about transversals, you can just draw an exaggerated one like this, like A equals B equals C equals D. So we see A equals B, so they're both big, huge angles. C is a big, huge vertical angle to B. D is a big, huge angle that's vertical to A. So, and E equals F equals G equals H. So this is a small angle, F is a small angle, G is a small angle, H is a small angle. So in the figure below, lines K and L are parallel. So, okay, let's go through how we got that answer that y minus x is 45. So, if we look at this, we get x is equal to y minus 45. How do we get that? Well, we extend these lines. So, this line where x is goes across here, and we can see that this and this are the same thing. This is x, that's x. We can see this is y, so from the transversal, we can see that this is also y, so that includes x, and it includes 45 degrees because this is a vertical angle. And therefore we know that this is y, and so the only difference between y and x is 45 degrees because we can see that y is equal to x plus 45. Okay. Question 10, page 558. In the figure, what is the average arithmetic mean of the 5 angles? Well, the first thing you should know is you don't need to calculate A. So this whole 2A plus 3A plus 4A plus 5A plus 6A. Yeah, the first time I saw this problem years ago, that's exactly what I started doing until I realized, no! You don't have to do that. Why? Because you know that a circle is 360 degrees. 360 divided by 5 is going to give you the average of these angles by definition. So you just go 360 over 5 equals 72 degrees. So easy. Did you find this video useful? Please like it and subscribe to this channel. Neither action costs you anything. You'll be alerted about my new videos. Why do I care? Well, it's simple, because YouTube doesn't let me share any ad revenue unless I have 1,000 subscribers and 4,000 hours of view time in a year. While many people are watching these, I don't have 4,000 hours of watch time. I don't have anywhere near 1,000 subscribers at the time of this video. I think I have about 720, so still need 280 subscribers. And for the same reasons, you are not only welcome, but encouraged to share links to this video, put it in playlists, etc. I'm always happy to read or respond, well, read and respond, because how can I respond if I didn't read it, to constructive criticism for suggestion, or I'll try that again, or suggestions for new videos. I reserve the right to delete comments from and block those who specialize in destructive criticism, trollers, people who have problems and want to take it out on you, things that are off topic. I definitely will delete things like that, whether it's from a spammer trying to sell a product or just a disturbed person who has problems and wants to take it out on my comment section. Anyway, contact me. You can call me at 415-623-4251. You can also text me at that very same cell number. You can email me at john@johnlinneball.com. You can mail me at 1859 Powell Street, number 109, San Francisco, California, 94133. If there's a copyright issue, please contact me. If you think I've used some of your work without attribution in a way that's not covered by fair use, etc., talk to me. Okay? And thanks for watching. And here's some more contact information. Contact me. All right, my Facebook, it's www.facebook.com, Linneball Tutoring. There's also an Instagram, which is www.instagram.com, John Linneball Tutoring. My phone number at my home office is 415-986-7355. As the old Joe Walsh song says, leave your number, maybe I'll call. Da, 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 da. Anyway, email me at john@johnlinneball.com. My website is johnlinneball.com. johnlinneballtutoring.com is also available.